Next we start with Coulomb's law, the force acting between two charged particles. Now the first thing, when you have two charged particles, if the particles are similarly charged, they'll have a repulsive force acting between them. If the particles are oppositely charged, there will be an attractive force acting between the two charged particles. So first thing, Coulomb law holds for point charges. Charges should be very small, point charges. Let us consider 2 point charges kept at the point A and point B, separated by a distance r. So there is a positive charge that is placed at point A, there is a negative charge that is placed at the point B, and the distance between the two charges is r. Then experimentally it has been found that the force acting between these 2 points is directly proportional to the product of their charges, and the force acting between the two charges is inversely proportional to the square of the distance between them. This law is an experimental verification. It has not been derived from theory. It has been experimentally observed when two charges that are placed at a distance A and B away from each other. Then the force acting between the two charges is directly proportional to the product of the charges and inversely proportional to the distance between them, the square of the distance between them. So we combine them, we remove away proportionality sign, we put F is equal to Q1 Q2 upon R square. Okay, where K is a proportionality constant. Now we substitute the value of K. What is K? F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. 4 pi epsilon naught. It is another constant. Epsilon naught is another constant which is known as permittivity of the free space. Here we have calculated the force considering that there is a vacuum between A and B. So the permittivity, epsilon naught, is the permittivity of the free space or the vacuum, whose value is 9 into 10 raised to power 9. Okay. So force, 1 upon 4 pi epsilon naught is equal to 9 into, numerical value is 9 into 10 raised to power 9 Newton meter square per Coulomb square. That is the value of 1 upon. Next we have Coulomb's law in vector form. Let us consider two positively charged particles placed at a distance from O. So Q1 and Q2 both are positively charged particles, and they are placed at a certain distance from O. The displacement vector from the point A to O is R1 and from B to O is R2. Then the force acting between, now these two particles are placed at a distance R apart from each other. Then these two particles similarly charged, they will repel each other. So you can see that they are repelling each other. This is F12, force experienced by 1 due to 2, and this is F21, force experienced by 2 due to 1. So the charge Q2 is exerting force on Q1. Here on this charge Q1 is exerting force on Q2. So we have the vector expression for the force exerted on 1 by 2 equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R cube, displacement vector R12. Similarly, the force experienced on 2 by 1 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R cube, or displacement vector 1. Okay, so this is the expression for F12 and F21. Now these two forces are equal and opposite. So A is pulling B, B is pulling A. Or A is exerting force awayward. So A is exerting force over B and B is exerting force over A. Now, the next very important point, if there are two positive charges, they will repel each other. If exert force in the opposite direction, if one is positive, another one is negative, then they will be attracting each other. In case if I would have taken Q2 to be negative, then in that case, the direction of the force would have been F12 in this direction and F21 in this direction. So they would be, the A would have pulled B and B would have pulled A. Okay. So my dear student, this is all about Coulomb's law for the point charges. Okay. And we'll continue in the next lecture for the electric field and the number of charges that are present. The force due to number of charges.